It's like I don't care about nothing, man. Yeah. Oh,
What's going on, guys? This video is going to be only about Circumcenter. So by the end of this one, there are two things that are very important to know about Circumcenter, and by the end you should be able to tell me what they are. Okay, so starting on page 7, up top where it says Circumcenter, I'm going to have you write two things. First is that a circumcenter is created by perpendicular bisectors. That's the first thing you might need to know. The second thing that you would need to know is each angle to the circumcenter is going to be congruent. So when we do example problems, this is what you need to know. You need to these are the two things when you set up problems that if you know those, you have to decide which one will help you more in this specific problem. So in each of the pictures, what I want to do first is do the marking so that it's actually a perpendicular bisector. So like for instance here at E, I would have a 90-degree angle and each side would have been cut in half, so I put a dash. F, another place, and since it's the second side I'm dealing with, I'm putting two dashes. Last but not least on this one, we have B, and since it's the last side that I looked at, we'll put three dashes. So we made the markings for these three perpendicular bisectors that meet to create the circumcenter. So anytime it's an acute triangle, it's going to be inside. So depending on what kind of triangle it is, the circumcenter might be in a different spot. So like for instance in the obtuse triangle, you notice the three perpendicular bisectors meet on the outside. So anytime it's an obtuse triangle, it will be outside of the triangle. So if I were to do the markings here, I still have it at E, put a dash there, F, and B. So each side got cut in half and it has the right angle. That's the perpendicular bisector part. And down here for the right triangle, they told us angle C is the 90-degree angle, so I'll go ahead and put that marking there. Now if I do the actual perpendicular bisectors, we have E. I'll put the dashes to show that these sides are congruent. We have F, so I'll put two dashes since it's the second side I looked at, and B. Now, when it was acute, it was inside. When it was obtuse, it was outside. Here, it's on the hypotenuse. Because remember, the longest side of a right triangle is called a hypotenuse. So I'll move it over slightly so you can see that. So these are the markings you would need to see for the perpendicular bisector. Now the second part, I'm only going to do it for the acute triangle on this one. But we also said that from each angle to the circumcenter has to be congruent. So if I were to draw those from the circumcenter to the angle, the vertex, it has to be the same length. So this would have to be the same length as it is from A to the circumcenter as well, which would be the same distance as C to the circumcenter. Oops, that line got messed up.
What an idiot.
But each of these have the same length. So those lines that I just drew in there would all be the same length. Now if I were drawing it on the obtuse, it would have been going out to it. But from the vertex to the circumcenter should be the same distance. So we're going to do a practice problem right underneath it and see which one of those is going to be important to us. Okay, so it says in the diagram, C is the circumcenter of the triangle XYZ. Find the value of x, then find the length of CZ. Show all your work. So notice that the arrows are pointing to the lines on the inside. So we were told that there are two things you need to know. First thing is that they're created by perpendicular bisectors. The other thing you need to know is that it's congruent from angle to the circumcenter. So this one here, notice the lines are going from the angle to C, which they told us is the circumcenter. So for us, these two lines that they want us to look at is going to use this property here, that it's congruent from each angle to the circumcenter. Now, if you don't remember what congruent means that they're supposed to be equal or the same. So if I do 3x plus 10, it should be equal to 2x plus 15. So the next step in solving this, I'm going to go ahead and move my x's. So I'm going to move 2x to both, subtract 2x from both sides. That will get me x over here plus 10 equals 15. Now, I'm trying to get x by itself, so I'm going to subtract 10. And when I get that, I have x equals 5. So have we found our answer yet?
We ain't found shit.
So that's correct. We haven't found our true answer yet. So now that we know what x equals, we are going to plug it in. So they want us to find CZ, which CZ was the 3x plus 10. Instead of x, we're going to put 5, so 3 times 5 plus 10. So 15 plus 10 is 25. So in this case, the length of CZ is 25. And since they didn't give us inches or anything like that, I'm just going to put units, 25 units. So that's the end of this video. Now, the problem next to it on page 7, I would want you to do for practice. So that's your practice for this. But now, you should be able to know the two things you need to know, like I was saying in the beginning, are that it's created by a perpendicular bisector and that it's the same distance from each angle to the circumcenter. So depending on what the question asks, you can use those two bits of information to basically set up your problems. So if you're dealing with the sides, you know that all the sides of the triangle got cut in half. If I'm talking about from the angle to the circumcenter, I know that it has to be, they're all equal. So then I would just be setting them equal. So depending on what kind of problem is which one you use. All right.